Hi everyone, welcome to the Kotlin London. It's been a crazy year, but finally we are in December and we are at the last event of the year. We are very lucky that we managed to keep on going with our events. We started with absolutely no experience in streaming live events and no budget. So month after month, we try to improve and we hope to we been able to give you some decent and good content. I want to thank you all of our speakers that's volunteered, have been absolutely great to give us always new and fresh content and always very interesting talks and different topics. But also we want to thank you, our main sponsor, 47 Degrees, that will be provided us with the stream for StreamYard, as it completely improved our experience for the streaming. So thanks to 47 Degrees. We also thank StreamYard. If you want to try it, let's go for it. We have in the link in the comments a link to get like a discount, and also will help to monetize a bit more for the meetup. Of course, if you haven't done it yet, join our meetup page. Subscribe to your YouTube channel and follow us on Twitter. We are already planning for next year. We already have some speakers lined up for January and February, so we're not going to stop. And we'll keep on going with online, and hopefully, if it's the COVID will let us, we're going to trying to get something face-to-face next year, hopefully. Right, as usually tonight we have two talks. We're back after the October event. That was a bit different. We're back to the normal two talks format, and first talk will be from Raúl, talking about reactive apps with asynchronous flow and stateflow to sync the UI. The second talk is from Hardik, which you probably already know because it's already been a speaker here a few months back at the Kotlin London. This time it was talking about Kotlin Multiplatform, sharing code between Android and iOS. So thanks for both of you, to being at the Kotlin London. Q&A will be done after the talks, and the link of the question will be here on YouTube through the usual Slido. As usual, after the talk, please give us more feedback in terms of like a comment or a thumbs up in the section. It's always helpful for the speakers that's talking online to have like a nice feedback. So that's enough for me for now. Let's start with the first talk, and I give you the mic to Raúl.
Thank you, Enzo. Today, I'm going to talk to you about full reactive apps with asynchronous flow and stateflow to sync with the UI. My name, as you know, is Raúl Hernández López. For who don't know me, I work at Twitter as a software engineer for the search team at the moment. Later on, you will be able to see the slides if you want to, if you follow me on Twitter. And also, you want to see the code snippets that you will see here. Those are in my guests under my GitHub username. That's RaúlH82 BLC. But let's go to the agenda. First of all, I'll introduce a use case, why everything will make sense, and why I did some choices about that. Then I'll introduce a migration strategy for going step by step without getting crazy and then becoming this legacy app I will explain in this case to be something more modern. I will introduce later on basics very quickly, because I think basics are super important to master things and also to better understand what we are trying to achieve. And then the longest section of this talk, which is implementation. That's going to be a bit intense, but bear with me. And then in the end, I'll explain you a few lessons I learned along the way and next steps that I think are interesting. Let's see the use case. About the use case, you can see that I was starting to type into a search mechanism. This is, by the way, a sample app that I created in my spare time. And you can see that you have also a detail of those particular items, and this is basically the results that you get when you are typing. So this is something not very complicated, but complicated enough to see a few use cases and what we can do to make this better. So we have here a few things like empty state, like if we have any errors, and also typing and then synchronizing everything from the moment we are typing. So we need actually a reactive mechanism. For that, let me go into the migration strategy that I think is relevant and interesting to explain. First of all, this application was built about 3 years ago, so that means it's very legacy. And if we want to migrate something, then we do need to do a big refactor. And for that, we'll need to follow some steps, step by step, just to make sure that we are not breaking things along the way. For that, in my opinion, analyzing previous architecture is critical for that. And by that, I mean, I had at the time something in the data layer with a repo and then some data sources, everything built on from the ground in Java. So you can see the repo is controlling different data sources, network, and DB, that means offline mechanism. This was connected with the business layer, that means for me, a use case or an interactor. The use case is requesting things to the repository and doesn't really care about where is this coming from, but it needs the results at some point. And then this, which is connecting the clean architecture with the presentation layer, is connecting that with the model view presenter I have at the time. This presenter is also built with Java, as you can see. So the presenter is executing this use case, and this use case is requesting this information to the repo, then getting those results back, and then this going to the view. Actually, everything started from the view because the user types, as you already know from the use case, and then those views are interacting with a view delegate, which is gonna decompose different functionalities in order to provide a passive thing to the view. So basically the view gonna be passive. Everything that is functionality-wise from the view gonna be done into the view delegate. And this view delegate will start this process, this reactive process from the presenter to the use case and to the repo, getting some results back, and then those coming with callbacks from the use case. As you can see, this is pretty legacy, but we'll see my proposal. So then we need to check the backwards compatibility requirements we had at the time, and then going step by step. So at the time, I had RxJava. Basically, we need to make this coexist by time being, because we're going to migrate this step by step. And then we need to actually analyze the different endpoints, because we need to come from one place to one another without breaking everything. That means if we have some inputs, we are expecting to have those outputs to be respected, because then we can migrate something and then go into the next step. And for that, we can see that we have RxJava all along the clean architecture side. That's from the use case to the data services. And also for hot observables, I have this from the view delegate, which is starting and triggering this mechanism from the Pasanta. Then if I want to migrate that, I will start, in my case, and in my opinion, you can change and do that from another place, obviously, from the database data source. So I will migrate that with Kotlin. I will introduce some RxJava, some coroutines, probably suspending functions. Then I will go to the repository, then using Kotlin plus RxJava again, because remember, if we are migrating things, we need to return those singles or observables, because those are the ones expected from the previous layer that is communicating with you. And then the same, once this is migrated, we can change stuff, and probably we don't need to have observables there in the data sources, and we can just rely in, let's say, flows. When this is migrated, we have those flows here. We can make sure that this use case is also validating that. And here is basically the case for the clean architecture side. But now we are going to the view delegate, which is also having some hot observables. That means for me subjects. And this can be changed using channels as flows. We'll see later. But then, if we want to get rid of those callbacks that probably are not the best choice, probably we can do a bit more. For that, I will suggest to use Stateflow. Why Stateflow? Because Stateflow gives us the opportunity to use things across different hybrid files. That means Java and Kotlin files. So we have this migrated from the whole use case and also the view delegate with Kotlin already. But we have a very strong and big layer in the views that cannot be migrated just yet to Kotlin. Then this can be used actually. But then if we are using Stateflow and we need to collect the results from Java, then we're going to need something else. We're going to need a collaborator. In this case, I called it a Stateflow handler. You can call it as you prefer, obviously. And this is the one responsible of processing those results and then initializing things for the view as a helper. So that's basically my approach. A few benefits I find about using this approach is, for instance, reusing existing elements. That also means architecture, because we don't need to change the architecture to reuse existing elements. The only thing we need to take care of is to have separation of concerns, because then we can actually change the things and making sure that with a black box kind of mechanism for certain inputs, we can have certain outputs, and those are going to be expected, and we can change also the tests along the way. Also, because we do use this kind of collaboration between layers, we can make sure that we are not having breaking changes, and if you work in future modules, you won't affect any other colleagues at work. But let's see now some basics that for me are really important to better understand calling coroutines in general. Let's start with what is an open stream. For me, an open stream is something like that. I say, hey, in Vulkan right now, and somebody in the other side, Christina, is right now practicing some maths, teaching some maths, whatever. But the thing is, I send the message, these greetings, but she answered me that. If we close right now this, that means that this is going to be a closed stream. It's one short request. But if we keep going and we have this conversation open because we are emitting more values, that means in a stream or in a messaging app or in real life per se, then we have an open stream. That's the case. And for me, it's very easy to understand that by having this example. But obviously, we don't need this for every case, right? We are not going to use always open streams. For instance, for network requests, because we're going to do some requests and maybe we don't need one another after maybe half an hour or more. So it's just one sort of request. And for that, what do we need? If we think in coroutines, we could use for RxJava, for instance, we used single that uses a not nullable value, and the correspondence to that is a suspend function returning an object. But if we need something that is nullable, then we'll use maybe in RxJava. Comparing that, in coroutines, we use a suspend function with a nullable value here in suspend. Then finally, for one single operations, then we have completable, which is the fact that we don't return any value, but we have a completable action in RxJava or a suspend function with a unit because we don't have any returning type. As simple as that. Then for threading, we're going to have schedulers in RxJava. So let's compare that. And we'll have also dispatchers for coroutines. They're going to be used for suspend functions, flow, Stateflow, and so on. We'll see later the different types. Then the life cycle, that probably is one of the most important things, in my opinion, about both things, coroutines and RxJava. For RxJava, we'll use disposables that can be disposed, that means finished, by disposables in this case. And then we have scopes for coroutines. And the scopes are even more powerful than disposables because they have superpowers. They have something called structural concurrency. This is very cool because structural concurrency gives us a few advantages that we didn't have with disposables. For instance, if we cancel this scope, we can have recursive cleanup. And by this, I mean something like this example over here. The scope is being canceled. That means that we have a few processes below this scope, process 1, 2, and 3. But the fact is that we're going to cancel all of them if we cancel this scope. It's going to be automatically done by structural concurrency. If we want to do something similar in RxJava, we need to dispose all of them manually or using composite disposable to attach all of them to one composite disposable. But if we have different layers, then we need to do for every layer in RxJava. So that's slightly different. So by that, we can have recursive cleanup, and that means avoiding memory leaks for free. So that's very cool with the static concurrency. Also, if we want to see something different and we want to make and avoid some side effects on cancellation, let's see this with a scope, which is basically the default, plus a supervisor job, which is a different type than job. Then we have something different like this. We can avoid other children cancellation. By that, I mean, we have this scope plus supervisor job, and then we have those three processes that we mentioned earlier. And this process one just got canceled because it thrown an exception. That means that probably we don't want to cancel 2 and 3. By having scope plus supervisor job, we can avoid that. And we have this in the root scope, having the supervisor job plus scope, we can avoid that. So that's very useful. Now let's see some implementation details and we'll dig into further things. For instance, first of all, related dependencies. I used in my latest version 1.4.0. I know that we have right now 1.4.20, if I remember correctly. But just for the sake of having things stable, I used that and I kept it. So we'll use that for both the Kotlin style library and also the coroutines version. And let's see this first step of the migration, data sources design with the network and the database. So we'll start here. We want to change all singles to return suspend functions, and then we'll return as the type a single for them. So let's see what is going on inside this network data source implementation. What I had inside is a Twitter API, which is basically a retrofit client with a HTTP, and then something for checking connection if we need it, and something to transform the requests and responses. Nothing else. This is a singleton because we want to reuse it in the whole app, so that's all. And then if we do have this method, what is a search, we'll have the token because it's an authenticated query for Twitter in this case, and then the query that the user is typing every time. So we'll search that with the token and the query. And in Java, we'll use the filter to check that everything is correct. So we go on, then we map those things to become those tweets from the DB. And then not from the DB. This is the data source network. We'll map those and we return those as a single because we are changing the maybe to a single right here. Then if we are changing this into coroutines and we need a suspend function. So for this particular case, I use either. Either has a few advantages. I will just mention a couple of them. There are many. This is actually very similar to Kotlin results. So it's something similar in that way. So we'll use that with the search query for the Twitter API. We'll return a response. We'll check that it's successful. Then we'll go on. And then we'll get the tweets from the network. And if everything is all right, we return this with either right in the tweets embedded there. But if something is wrong, the left side, we'll be embedding this with the wrong response, something very similar to result in Kotlin. Now, if we want to return this as a single, then we have something very handy. That's the library called Kotlin coroutines Rx2. Because by using this block operator with Rx single, we can return this as a single. So this is very useful because then we don't have to migrate right now the repository. So we can just do it for another day. And then for the library, I use room. You can use anything else. And I return also a single type. As you can see here, my query is just selecting everything that is in my table of tweets, by returning those things coming from the IDs that I am passing in, and then ordering by descendant order. Nothing else. Let's go to the repository design and the step 1 to learning a little bit. And also I'll mention that this is my naive approach because I made some mistakes and I learned from them. And that's why I came to this kind of first approach, which is my RxJava approach because I came from the RxJava world. And let's see, repository call using Kotlin plus Flow and RxJava. So we'll return here an observable from the repo. So the repo is basically having the network data source interface. That's the one we mentioned earlier, and the different tables we had in the DB. That's the tweets database, token, the query, and the combination of the query plus the tweets, this kind of intersection table. Then the different mappers to transform things from the network to the database, and then finally something called task threading that we'll see in detail later on. Now, the method that I use is get search tweets with the token and the query, returning an observable with a list of tweets. So we'll use the network data source into the repo by searching the query, passing the token to authenticate this request to the network. And then we'll subscribe to the IO because this is an input-output operation. And we'll observe in computation if we need to do any operations later on in the computation thread pool. We'll map those results with the mapper, getting those results back from the aider operator from the arrow library. And then we'll do a next with the tweets we want to add to the database. We'll do a kind of updating mechanism by deleting first tweets, then inserting the new ones, then inserting the query, and then inserting those IDs from the tweets IDs to this combination table. You can do actually an update, but I decided to use this strategy for deleting and inserting. Then I did a flat map to combine this in a sequential way. So I retrieve those things from my query that is already in the database. And finally, with those tweet IDs and the query that you checked a moment ago, I'm going to return those tweets, a list of tweets in the observable that we have in the return type. If we want to do the same with flow, my first approach was returning a flow right here, and then using exactly the same operators, a map over here on each instead of doing next with those things I mentioned a moment ago, and then flat map concat instead of flat map. Nothing different than the thing that I had before. So it felt really, really cool because it was super similar. Nothing else to change. Just the return type gonna be a flow. And also for the database, I'll do the same. I'll return a flow because Room is prepared for that. But then we need to do something for subscribe on, but in this case for flow. We'll use the flow on operator. The difference that we have from the subscribe on and flow on is the fact that flow on works upstream. So if you want to use it in the previous things, you need to put it down, all of them. Then those want to be affected by the IO dispatchers we have there. And then the task trading, that is the thing I mentioned I'm going to explain into detail. I use here different schedulers, so for the computation one, for the input-output, and for the main thread of Android. So I expose those methods into those, those instances into those methods, and then those ones can be mocked for different tests. But then, if we need to use these for coroutines, we need to use dispatchers, coroutine dispatchers in this case. So I created a few series of methods to have exactly the same equivalent. And then what do we want to do if we want to reuse them? Actually, if we don't want to have 6 resources in memory, but only 3, this is absolutely possible. If we want to do that, we can just use, again, the same library and using the coroutine dispatcher operator that we have into this library. This is going to convert this into the coroutine dispatcher, which is super cool. And we return this in a coroutine dispatcher way, just using those 3 same things that we had earlier. Now, by using that, we can return the observable because it's the thing we are expecting to have in the use case. Then, if we want to go to have a step forward and then going a bit more pro, just leaving that and having the native way to use coroutines, then probably we need a suspend kind of approach. So we have migrated everything already until here, and we don't expect to change this repository with those things. So let's see. So changing that, if we only want one shot operation, this is enough to just return suspend. So to have this close, suspend, and then returning list with tweets. That means we don't need anything else but the list of tweets because the suspend function is going to be responsible to do that. And then we'll do a coroutines way by having imperative code right here. So we'll do those things that we did earlier. We'll return this from the search network data source, and we'll map those. We'll do the same operations than earlier. We don't need to tell them anymore. And then I try to experiment with something else. As you can see here, I try to return a flow into a spam function, but is that even possible? Absolutely not. This is not possible because we have a one-shot operation. That means we need to return as a spam function. And we can do something like that. We can return as a spam function if we need it inside another suspend function. So if we need to do that, we need to change also the database, and we return as a spam function over here. Then the tweet repository returning a flow. So for instance, we can do something like that. If we want to do, let's say, the use case of a poll with a database being refreshed by the network every 30 seconds per se, that means if we want to have this from another entry point, and we want to change and refresh the values from the UI, by emitting all values right here, we can make sure that this is refreshed every time because it's an open stream that we mentioned earlier. And also using the flow builder. The flow builder is super handy because it's gonna allow us to use emit all in this case, and a few more that we're gonna see in a moment. For instance, this, if we want to return just one value, we can do emit and returning the suspend function that we had earlier, the retrieve all tweets from tweets IDs. But this is one-shot operation, so this is not the best use case to use that because it's one only emission. For that, we can just replace the return type to a list of tweets and adding this span modifier to the get search tweets. But let's see another interesting case. For instance, here, if we want to use the flow builder, we can emit different values more than once. Let's say we want to show first the dirty values of the database. So we're going to emit the values from those retrieve all tweets from tweets IDs. And then we can, as soon as we have this refreshed, emit the new values that are fresh from the network. So we could have this kind of offline mechanism. Of course, using flow on upstream and using the IO dispatcher because it's an input-output operation. And we'll need to use an observable right there. So we'll use as observable to change the type. Again, using calling xroutines Rx2. Now let's see what we have in the use case design. For the use case, I am planning to have everything else change so far. So here I am expecting that I'm going to return a flow, and then the use case is going to be responsible to handle that. But let's see what's the difference between the previous approach and the new one. For instance, search tweets use case with the constructor, I have inside here the repository, and again, the task threading. This search tweet use case that is in a routine scope just for changes, configuration changes, is going to use this use case interface with a callback right here. So this interface, this contract, is basically having a parameter that is the callback, and then the first parameter in the execute is the query, and the second is the generic type, that is the callback I am expecting to pass right there. And then the cancellation method, that's for disposing in RxJava world. Then for RxJava, the difference is RxJava plus Java. So I am executing this from the use case. I pass the query, I have the callback is initialized. I check that the callback is not null, and then if it's not null, then I pass the callback, and I show this dialog that I have at the very beginning when typing the query. That's the loading state, and then the callback do the on-show loader. So we'll see this kind of dialog pop up that we saw to the user when it's loading the results. Then we'll do the search tweet query in the repository. We'll subscribe, so we'll pass actions that are successful into this very first step of subscribe. That's using the callback with on success. If you have any problem, then we'll use on error on that for the error handling. Then we'll basically subscribe to the computation because we're going to do some computations maybe. And we'll introduce this map for doing those computations if we want to. But we'll observe this in the UI. So that's why we'll use the task threading.ui. Then we return the type for the life cycle to this disposable, and this disposable going to be canceled or disposed later on. But if we want to do the same with Kotlin, I change that. So the execute method going to have the same parameters, callback right there, Kotlin as you can expect. And then going to use for coroutines a scope. This scope going to be used with a launch method because we need sequential operations right here. I won't explain anything related to parallel because this is out of the scope of this talk, but let's focus into this sequential approach. So as you can remember from the previous introduction, I use supervisor job because I am avoiding side effects. That's why I use that from the coroutine scope. This can be here, it can be injected into my use case, and then I want to launch that. I'll make sure that the search tweet is making this, so I'm gonna map that, exactly the same, and then flow on gonna be there because remember this is upstream and needs to be down the map, up, basically below that, and this is gonna be in the computation dispatcher thread pool. Then, if we need to catch any errors, I'll also add this catch operator right after flow on, because we need to catch those things, and those things need to be in the UI if it's a callback. If we need to do anything else, that's another thing we need to do in the other layers. But for this case, the callback gonna pass to the UI, the on error thing with the different states of the problem, and then we're gonna collect the results, the right results from here. So we'll get the tweets. I'm gonna pass the tweets with the callback on success right there. Also, this can be done in this another way. If we don't want to have this verbose scope.launch, we can use launch in that by default does it for us. And actually on each, we're gonna replace this collect. So it's a same functionality, catch over there, that's gonna be all. Then, if we need to cancel this for making use of sort of concurrency, we'll use the cancel method, and then we'll cancel the scope to start concurrency. Obviously, we'll nullify the callback to avoid memory leaks. And then, if we need to do the same in RxJava in the old times, we need to do something like that, making sure that it is there, that it's not disposed, and dispose it, and making that null. Something very similar, not a big change. Now that we changed this, all the clean architecture side, we can just remove the as observable from that library I mentioned earlier and just return as a type the flow. Let's see what we have in the view delegate design. So the view delegate design, you remember, is basically the helper of the view. That makes the view totally passive because I don't want to get any responsibilities in my view. And it's gonna have the view listener for the search view that we'll see in a moment from the Android native component. And we'll start this reactive mechanism by the hot observable. And then we'll replace this from RxJava to channels. So first of all, this is gonna be in an activity scope. We'll introduce as a dependency a presenter, the search tweet presenter, and I will create a publish subject. That is basically the one responsible of passing a string. That's the query. I'll prepare this with the search view. That's the native component of Android. That can be another text, of course. That's up to you, really. And then this views listener gonna pass the publish subject as a parameter. This listener needs to be set up to the query text listener of the view. But then let's see what we have if we want to use channels over here. Basically the same parameter, we use the presenter, then we pass search view, we're gonna pass a flow when it's a call flow. But first of all, we'll use a channel flow for this particular case with a string. We'll define the listener inside into this block of channel flow, and we'll pass a channel inside this search view listener instead of the publish subject. Interestingly, you can see right here, please pay a little bit of attention, channel is not initialized anywhere. You cannot see this declared, you cannot see this initialized because channel flow builder is making this instantiation of the object for us. So we have this channel for free from this block. That's very interesting. Also, we could use a wait clause to make sure that anytime that the scope is canceled and we need to cancel everything with static concurrency, the view gonna nullify this text listener to avoid memory leaks from the view. That's very relevant. Then, if we need to do the same with disposables and RxJava, we need to pass the disposable, and when canceling that, we need to make sure that we are nullifying the view into here. We need to do it manually here. And then disposing that, canceling the things from the placenta to avoid things from the clean architecture side. And the search view listener is basically having this public subject that we already mentioned from the RxJava world. And the listener, the search view on query text listener, has a couple of methods. I will only use the on query text change with the query. But what we need to have here to pass the whole observable is the public subject with on next. Then it'll pass the query every time we need it. Obviously, you need something else like behavior subject. You can change public subject for that, or you can use something else. If we need to do the equivalent with channels, I suggest to use send channel because it's a synchronous operator. But the thing that it uses, offer in this case, send channel actually uses offer you want it. This will make sure that we are synchronous communicating that by making this synchronous with the UI. Then, with the view delegate and RxJava subject, when we are collecting the results, we'll pass this disposable, we'll use public subject, and we'll observe into the UI thread. Subscribing into the computation thread if we want to do any operations, and then we'll do the bonds. We need to have some delays for the queries. We'll make sure that we are not having the same query just to stop the triggering this mechanism if we don't have any different. And then the filtering of that, because maybe we don't want to start the query when we put a Husky or an at, let's say. We'll subscribe, and then from that point, we'll start the search tweet from the placenta. And if we have any problems, we'll show us something from the placenta as well. If we want to do the same with channels, this is actually the flow that we have retrieved from the block that we saw earlier. This is exactly the same operators. So that's the bonds, that's distinct altitude change, that's filter, and that's flow on. That, remember, is upstream. So everything that is from filter to the top gonna be under the computation dispatcher. Then we'll use on each, we'll search the tweet from the query, we'll catch any problems there. And interestingly, if we use this catch until the on each, it also catches the problems from on each. If we use collect, the thing you need to do is actually embedding everything with a try catch. That's the main difference here. And when canceling that and canceling the scope, we're going to cancel everything, starting the structure concurrency, and then making sure that everything needs to be cleaned up from the placenta and the architecture side. Cool, but are we done with RxJava so far? I have to say no. We have a little bit more work to do. For instance, we need to make sure that the tax trading is migrated totally. And by that, I mean, we used earlier the different schedulers, so probably we don't need them anymore if we have get rid of RxJava. We can remove those. We can just use the native ones instead, still 3 resources in memory only. And then I'll pass the different things to the default methods to be used anywhere. And now let's see the latest step of the migration, the synchronous communication design. By this, I mean getting rid of the callbacks. So you remember, we're going to start migrating the things and using the Stateflow, returning the results inside this Stateflow. So let's start. In the search tweet use case, I passed a repository and task threading. This doesn't change, but now we don't need to use the same use case interface contract because we're going to use something different. We're going to use the use case flow. And this is composed basically by the same methods, but change in execute, because we don't need anymore the callback. And also we need to expose the Stateflow. This Stateflow is gonna be the return type, and it's gonna embed a tweet UI state. We'll see later what is this about, but it's basically a seal class. And it's gonna be nullable in this particular case. Stateflow, as I mentioned earlier, can be passed across different Java and Kotlin files, so that's gonna be very useful for this particular kind of hybrid project. And then for the use case, I will instantiate into this use case my stateflow. So we need to instantiate a mutable stateflow, and we'll make sure that we are doing that with the tweet UI state that is nullable. I want to mention that this is nullable for the sake of doing this quickly, but the right thing to do is having this non-nullable and then making sure that we are covering all different states. For instance, the idle state with nothing when nothing happens. Then I will expose it with get stateflow, and I'll pass this tweets UI state to whoever stakeholder needs it. Then good thing about stateflow is that by default uses distinct alt-int change, and that means that if you try to do this alt-int change to the stateflow, it won't have any effect. Actually, it's one of the crossed methods you go to the documentation because it's already there. It doesn't have any extra functionality, cannot be done. So tweets UI state is basically the composition from this seal class, this contract, with the different safe types we need, and the data class with list results UI state, embedding the tweets. That's the successful tweets results that we got. Then our UI state with the message that we need to show to the user, and then the empty state. You want to just show that we don't have any results for this particular query. And then we want to show the pop-up again. We need to have a loading UI state. Now, if we started to migrate that, basically we need to obviously change and remove the callbacks lines. And stateflow just have a setter that is set value, or in this case, value. And we're gonna make sure that we are passing the state with the loading UI state. So this will trigger this mechanism, and we'll see right now the pop-up we render that to the user. So then for the search tweet query, we'll make sure that we pass another state right there. We'll make sure that there is not empty results, but if there is, then we need to pass an empty UI state. That's all. But if we have any results, we'll pass the list results UI state with the tweets. And then we'll make sure that the value setter will pass this stateflow. So this is going to be super quick, actually. Then we'll catch the different problems, and if we have any, we'll pass the error and we'll show up, and we handle that later into the UI. Obviously, it needs to be, again, with the launch in scope. This didn't change. But now, interestingly, we need to make sure that the stateflow handler is making this collected. By that, I mean, we have the search tweet presenter with the use case, and this search tweet presenter gonna have embedded this use case, and this use case gonna be canceled, and we're gonna need to pass again the stateflow from the use case to the other layers. But interestingly here, obviously we remove the callback. So we use the same methods we explained a moment ago, but we get rid of the different callbacks that we don't need anymore. And we'll expose these to the other collaborators. In this case, the view delegate. We'll expose that from the presenter to the view delegate, and then we'll initialize the processing query. For that, what I did here is passing the search view and the tweets list UI seal class, and I initialize this with the stateflow. As you can see here in the get stateflow is the one exposing this from the presenter. So this method is actually there into the tweets list UI. That's something like a fragment, a custom view, or an activity. Into there, I injected my view delegate and also my stateflow handler. So I initialize the stateflow handler with the stateflow plus the reference to the view that we're gonna use. And then we'll process this stateflow when it's required. This init stateflow, by the way, gonna be used from, let's say, on start. Stateflow handler actually gonna be in the activity scope. So we initialize that, we initialize the things as we are expecting. And into the stateflow handler, I will make sure that it's late in it because it should be initialized at the moment we have a stateflow, not earlier. Then, when we have this there, we need to collect it. So we're gonna do a filtering because we have a nullable state here. We will have every single use case we are not going to need actually a filter. So that's something that we can improve in the future. I'll do on each, and I will handle those states with the Stateflow. I will make sure that the scope is there in the launch in, and yeah, with that we have this collected. But let's see what we have in handle states. So that's basically a stem function from Twitch UI. That's the view that we saw a moment ago. And we'll make sure that we are handling on states. So first of all, type save, and we're gonna show some loading when we have this first loading state, or we're gonna show some results when we have some tweets coming on, or we're gonna show an empty state if we don't have anything to tell to the user, or a problem, or if we want to have this by default with an empty state, we can do it, or we can show something else. Then in the Stateflow handler, we'll cancel everything to make sure that we cancel and we make sure that static concurrency is working for us. And we'll make sure, because this is a helper of the view, that the null, the reference of the view is null, because we don't want to have memory leaks. Otherwise, we want to have it. And then from the view, we're gonna make sure that when we do launch on the story from the activity, this is launch, and we are canceling everything to make sure that there are no memory leaks. So that's all for the implementation. We're gonna have right now with this approach a full reactive with flow done, with all types of flow that we need for it. But let's see a few lessons learned along the way. For instance, exchangeable. What I mean by that is that we can reuse observables, singles, and in this case flows, and suspend functions, and change them as we want to. This library I mentioned is very useful because you can do the opposite way. You can actually change the approach, and instead of changing to coroutines, you can change from the other layers and coming from top to bottom. I did from bottom to top, but it can be changed. Also, static concurrency is super cool because we have a few advantages of this recursive cleanup, or we can have completable flows. That's an observable that is completed by itself, or yeah, a few advantages like that. Also, we have a pressure that I didn't mention, but you have also a pressure with flows. But the problem of static concurrency is that when it's gone, is gone actually when we are doing this migration. The problem is because we are passing observables from one layer. You are actually having here in the down layer those suspend functions. You return the type as an observable, but you want to have here static concurrency is not really possible because you change that to an observable, and this observable needs to have actually a life cycle that needs to be covered and needs to be handled properly. So yeah, that's the main problem I see here. And then imperative against declarative. Always I like to put this mem because I really like the fact that when you don't know how to work something like the naive approach I mentioned and all those kind of things, I try to do a declarative way, and then I realize that it's not the native way for them in coroutines. So for suspend functions, it's better to include them in an imperative way, and you don't need to overcomplicate with declarative way, but yeah, it's a bit confusing. When you are very used to RxJava and then you switch to coroutines, this is mind-blowing in my case. But yeah, maybe you do better than me. Then, just to summarize a little bit, there's few pros and cons that I saw is that basically RxJava is purely declarative. You're going to have a set of operations. You going to care more about what you want to do more than the how, that is the imperative way. Then coroutines and flow for suspend functions, you're going to do imperative. For flow, if you do emit, it's exactly the same, going to be imperative. But then if you're going to collect things, you're going to handle them, then this is going to be declarative. So you need to actually master both of them. RxJava does manual lifecycle handling, unless you do any other library on the top of it. You use any other, then this can be done as well. Coroutines as flow with static concurrency is super cool. It has a few advantages that I really, really like. RxJava is good for hybrid projects, unless you have some crazy wildcards that it's not being covered, but maybe you need Kotlin instead. And then if you don't need Java because you are super lucky, then you can just use coroutines as flows and friends. That's perfect. You don't need anything else. Then next steps, just to finish this this bit. waiting for stable flow APIs, but I think right now is everything or mostly everything is stable. Everything but the bonds, if I remember correctly, is not stable. And some APIs like this send channel so far. For the rest, Stateflow is actually stable. Also, Servflow is stable, and we have a few things that are coming on. So it's super good time for do that. So we're gonna avoid to have deprecated very soon, and you can be happy to go there. Special thanks to Manuel Vivo who helped me for the first and the second release of those slides. So thank you, Manuel. And thank you for attending today. Thank you for inviting me today to Kotlin London. If you have any questions, we'll see that later. But just very quickly, if you have any questions about anything that I explained today, I wrote a series of articles that you can read later on. So I'm going to share that later. You have this in the slides, so you can just download the slides and click one of those articles. I have a series of 7 of them. And yeah, if you have any questions, more than happy to answer now. Thank you.
See the questions. I just popped it into the.
Yes, it's a bit small. Thank
Is
you.
it better? Yeah.
I'm gonna increase it even more, but I think it's okay, no worries.
Yeah.
Are you using Flow and Stateflow at Twitter? Okay, bear with me. I wish. We don't. I started actually this investigation and all my work last year to now, just to at least investigating and see a few advantages. And this is actually something that I explore because we have a lot of legacy code that is into Java, and it's very difficult to migrate that with this amount of code that is combining Java and Kotlin, and also because we rely also in the different dispatchers that we use. Well, in this case, schedulers for more things than our servables. We use them also for libraries like Fresco. It's a bit like a bit of complicated, but yeah, we are in the way at least to think about it. Second question, in multi-module app architecture, where, okay, when I increase it a little bit the font because I cannot read it properly. In multi-module app architecture, where networking module is having RxJava and used everywhere in other modules, what migration strategy you will suggest? Okay. Let me read it myself again. In multi-module app architecture, where networking module is having RxJava and use everywhere in other modules, what migration strategy will you suggest? So basically what you are asking is the fact that you have RxJava and you are feeding the other modules with RxJava. So what I would suggest is basically if you need to use something with dispatchers, but well, dispatchers in this case flows, but you have still observables. The fact is that you can use these to observable if you need to change it, and then starting to migrate one thing with one another. So basically, in my opinion, you could start migrating things to suspend functions and then returning observables and singles. That's the approach I followed. But yeah, if you think anything else, obviously there are more ways than that. Okay, next question. Have you found any Rx bits hard to migrate to coroutines where the parallels are not so straightforward? Okay, I'm not very sure if I understand that, because where the parallels are not so straightforward, that means parallel like async, or that means anything else?
I think there's when some parallels between Rx and coroutine if you just switch between like a a function in Rx and function in coroutines, and when something is less obvious.
Mm-hmm. Well, in my opinion, the things that are very hard to migrate are probably the things that are a bit more different. So, for instance, channels is a big thing itself, and channels is complicated to understand, and I think everybody thinks in a similar way. Basically, that's why, for instance, conflated broadcast channels are gone, and on behalf of that, we have now Stateflow, which is a super focused and simple API, and Serflow, which is both of them are replacing broadcast channels. So channels is a way to communicate different routines, but I think is a very complete but difficult API. So for me, I think channels is probably the most complicated thing because you need a big understanding of what is going on behind the scenes to have a good benefit of the usage of channels. So I will say that channels for me is more complicated than Flow, which is very straightforward. RxJava and Stateflow and so on. Thank you. And next question, Jorge. Based on your expert experience, what do you prefer, live data or Stateflow, and why? Okay, here let me be very honest. I don't have any experience with live data and say that in other meetups and other talks I gave. But I know because there are different articles I read that actually Stateflow is equivalent to live data in the same functionalities. But if you are following the different conversations that there are going on in Twitter and Slacks, advantages that you don't have with the Stateflow that you have with live data. Live data, because it uses a few helpers with architecture components, uses launch when started or start. You can read that in my latest article about Stateflow, that it makes sure that you use it only when you have started on a start of in your application. Stateflow, the fact is that doesn't care about states. So sorry, it cares about the states, doesn't care about life cycle of Android, because Stateflow is meant to be used anywhere. You can use it in Android, you can use it in backend, you can use it in multiplatform. So that's basically it. You use Stateflow, you need to make sure that you are handling the life cycle of your application correctly. Otherwise, you're going to have crashes, unexpected crashes when you go to the background, because Stateflow also works in the background. So that's my tip of the day. Serving. What to do with use cases that need to be executed consecutively and have multiple scenarios to handle? They are hard to maintain, in my experience, hard to avoid. Okay, let me try to understand this serving. What to do with use cases that need to be executed consecutively and have multiple scenarios to handle? Well, I don't know how you have your use cases, but use cases normally are supposed to be atomic or at least have single responsibilities. That's why clean architecture is done in that way. If you need to do consecutively them, I suppose you need an orchestrator for them, because this is a more complicated scenario. So probably some way to do that is to use state flows as the return type and then get into a place to synchronize them. But state flow is meant to be used for a single collector. So you need to have an orchestration of that. Probably share flow is better because you are actually doing a broadcasting of those operations. And share flow is precisely for that. It's a broadcast conflated channel. So you need to handle those. You can return those types. And in another higher order, higher function use case, you can do that with a share flow. I suppose that's the best approach, but they are hard to maintain in my experience. They are very hard to maintain. I agree. And how to avoid? Try to be and make things simple. Maybe there are things that can be made simple that they were already. I don't have a generic solution, but yeah, decomposing the problem and trying to make that simple, I suppose, is the best way to go. Sometimes it's not possible, but yeah, this is what it is. Next question also from Servin. Is the refactoring that you did today a recommendation for MVI as a state are already mapped to states? I suppose you can say yes from my experience, but architecture is something different to the purpose of this talk. That's why I didn't really care a lot about different architectures. I just relied in the one I had, which is MVP plus clean architecture. But because you use states, you can take advantage of that and then using MBI. But MBI is a bit more complicated than just states. If you truly gonna do MBI, you probably need a reducer. You're gonna need to make sure that you use unidirectional data flows, which is slightly more complicated, and you're gonna need to do some work behind the scenes that I didn't manage to do into here. So it really up to you how difficult you want to make that. But yeah, for sure, Stateflow helps to use MPI for sure. Okay, I think that's all, unless there is any other questions coming on.
You can go. Hardik, can you hear me?
Yeah,
Okay,
let me share my screen.
perfect.
Hello everyone. So as you can see, my today's topic is about sharing is caring, KMM for Android and iOS. So let me start my talk by referring to some of my previous experience with KMM. So when I was writing my book, I wanted to include this particular topic. I did some spike around that, and then I find this topic very interesting, first of all. So I got some success doing it, but then I also realized that it is not up to the mark. I mean, developer might face some challenges while they want to accept this particular point, and it was not really ready for using for any of the big scale project. But after 6 months, suddenly I visited a particular page on their website, and I found that they have made an incredible changes, and now this topic is even more interesting. Working on this concept is far easier, and then it makes your life so easy. Even if as an Android developer, if you don't know iOS, that is also not a big deal to start with it. Of course, eventually you would need iOS skill as well, but I feel your iOS buddy would help you there. So let me share idea why I came up with this talk now. So there are some motivation factor for you
Hardik,
guys. I will.
sorry. Can you share on StreamYard the slide because not visible?
uh,
Sorry about that.
no, it's okay. There you go. I think now it's good.
No, you have to share it on StreamYard. Okay. There we go.
There you go.
Now it's, yeah, perfect.
Yep.
Thank you.
Sorry, guys. That's me using StreamYard for the very first time. Okay, so yeah, let's begin. So the motivation point for this particular talk is, imagine you want to develop you want to develop some concept in both Android and iOS, but you don't know where to begin from. So, and you don't want to do the job twice because you are a very good software engineer. You just love drive principle. So and also admit that you don't have iOS expertise. You are an Android champion. Um, you never want to compromise on the quality or maybe a swift delivery. You want to deliver the feature faster with top-notch quality, and of course you don't want to compromise on some of the best practices which Android and iOS offers. You love the way view model works, you love the way repository patterns make stuff easy. You don't want to do compromise on it, and also somehow you don't like the existing cross-platform technology, maybe like me. I'm not fond of all those things. So yeah, so that was a bit of an abstract part, but then what actually KMM will do for you is you would end up writing code once and you would be still able to use it on multiple places such as Android and iOS. It has a wider scope, but for our talk we are keeping it up to Android and iOS only. It reduces the testing effort greatly because you can definitely assure your QA and your team that if a feature is developed for Android, it would behave same in iOS as well if it is written inside your shared module. It has a less maintenance headache and modification comes super easy because you only modify the code once and you get the same output on both the platforms. Another, of course, it has a great benefit of language like Kotlin, which is doing amazing. It's been 3 years. Kotlin is rocking into the dev community. It's statically typed language. You don't get surprises like other JavaScript framework. And for Android engineers, it doesn't really change anything. It's just like your day-to-day work. I would say you have that Android Studio window in front of you. You keep writing code either in shared module or Android application. It feels the same. And for iOS engineers, I would say they don't need to care about whether code is written in Kotlin or Swift because at the end, what KMM gives as an output is nothing but the dot framework file. You might feel it as a just like any other Swift framework, and then there is no difference. And here is the main thing. So KMA is for everyone, not just for developer. Even this point would make your stakeholders happy. If you plan it very well, it can reduce the development time of 30 to 40%. That means you deliver the features faster. Now, I was saying about that KMM is all about adhere to the best practices and respecting what platform offers. Now nowadays, if you can think of any modern app architecture, they would have four major categorization. I would say data layer where you can keep your HTTP calls, caching mechanism, stuff like that, and then comes business logic on top of it. You can have use cases, interactors, or maybe some of your common utility function. Presentation logic, key part, view model, presenters, and those sort of classes. And at the top, it could be your activity fragment, view controllers if it is iOS, things like that. So it has been divided into all this part. Now you might be thinking that, okay, can I share each and everything? Answer is unfortunately no. What you can share if you are using KMM, so you can share your data layer and business logic in a 100% manner. Presentation logic, I would say it's possible, but based on my experience, I would suggest not to use KMM for the presentation logic. There are reasons because presentation logic is really coupled with all the platform practices. iOS has their own way to do the stuff. View model has their own way to make the things work for you. For example, they are life cycle aware, configuration changes aware, many things. And KMM hasn't reached that point yet. So I would suggest on the presentation layer, keep the way you are doing right now. Now, those who has some experience on cross-platform technology, they might think, okay, why can't I use Flutter? Flutter is doing great. Xamarin, React Natives, they all are from giants and well-established, well-trusted companies. I would say I also have experience on working some of them and even older framework like Cordova stuff. But let me again share what I feel about them. I have no grudges for them, but I would say they are pretty good for MVP and idea validation. Of course, even I would go for it. But then what I feel is they don't allow you to follow platform specific practices. I mean, come on, you can't use view model if you are using, Xamarin or maybe React Native. They might have their own practices, and you need to respect it. It's not ideal for large or complex application. You won't design your app in Flutter where you have heavy requirement of taking care of security concepts. Of course, you would say no. C and C++ is a big contender, and it has an amazing potential, but you would end up changing the language as an Android engineer, and you may not be that much expert in those languages and not comfortable to work on. And all on this cross platform technology, you basically started feeling lonely as in you don't have much of a dev community support. You won't have much of a teammate around you when you are stuck and looking for help, and you struggle to deal with native APIs. Like, you would be always in question if you want to use something around location tracking, or maybe camera, or any other native functionalities. You would struggle, like even NFC maybe. I don't know if there are bridges kind of utilities available by all of this framework. You need to evaluate a lot of things before you pick any cross-platform technology. So these are the problems I feel and thought to share with you. And they also enforce the entirely new tooling system. I mean, you would be out of your comfort zone. Android Studio is an amazing ID. Every engineer would dream about it. So, and you would be out of that. So, yeah. Now, let me share a bit more around the architecture side. So how this entire things works. We're gonna take the example and learn everything step by step, but let me help you to start visualizing what we would be doing. So imagine there is a shared module. Now you can keep it, think like an existing Gradle module in your project. So think of some module. In that module, let's say you have a class which has two functions, like get job info and get OS related information. And there you have a common implementation. And if you want to be, I mean, if you want to go a bit different for either Android or iOS, KMM allows you to be that flexible because they know what could be the requirement for many of the real-time applications. So you can try to differ with the default implementation, and you can say, okay, I would just override get OS information and do whatever I want. And iOS team might be saying, okay, I'm also gonna override and do whatever we have as a requirement in iOS. And at the end, if it is Android, you get .jar file as an output, and then you just consume it like any other jar file in your Android application. If it is iOS, as I said before in the introductory slide, you get .framework as an output, and you just import and link this framework file using your Xcode and get the app running. Your iOS app won't even have idea whether it is the Kotlin code or Swift code. For iOS application, it's just a framework, and that's the big deal. So now let me quickly cover how you can set up the KMM. It is pretty easy, and you would find it on the JetBrains website as well. So what tool you need is, you need Android Studio 4.0 and above. Of course, to write Android and shared application, you need Xcode 11.3 and above. You might want to do some quick tweaks on your iOS code before you run them. Though you can run the iOS application from Android Studio as well. Yes, it's possible. New Android Studio is having all this facility. KMM plugin. So you just need to download the plugin from the preferences, and then this help you to select particular option into the project creation wizard. And then Mac OS. That's a bit of a constraint because right now, if you don't have Mac OS, you can't do anything. And the reason behind is the entire iOS ecosystem. The whole iOS ecosystem runs on Mac, so you have to use Mac for that. Okay, here is a plugin I was talking about. The plugin is compatible with, I think, Kotlin 3 and above. So make sure you are using that specific Kotlin version and the newer Android Studio, of course. This is how you would see a new option available into the wizard where you can select the KMM application like I'm showing here. And then once the project is created, you would see this kind of a lengthy directory structure where this root directory is a combination of three projects. One is Android Job Finder, which is your Android application. I have named it as Job Finder. Second is iOS Job Finder. That's your iOS application. And the third, the key part is shared module. And that's where your shared code would live. Okay. So now let's understand what is the use case here. I I haven't taken fairly complex problem, but I have taken still relatively complex problem, which would help us to evaluate all the scenarios which you would face in any of your project, let's say. So use case is pretty simple. You can see in the GIF, it's running. What you need is you need to display list of jobs available within UK. You want to allow your user to click on any of the list item and go to the detail part. And of course, information would be fetched from server. You want to write code using native components, no JavaScript framework or nothing like that. There to strong testing strategy. You don't want to compromise there. So with all those things, so I evaluated KMM on this parameter. It could be many other parameter for your project, but I think these four are good enough to show the potential what KMM can do. Okay, so now you must be wondering, what are we sharing? And so again, now try to recall what we understood using our diagram previously, where I tried to explain the shared module part. So inside your shared module, you're gonna have a Ktor. So Ktor is nothing but the API client, or you can say simple HTTP client, which would help you to fetch or connect to your remote server and get the data. Ktor under the hood uses Android engine. So they have concept of Android engine and iOS engine. Android engine uses HTTP URL connection, which is the core class to make HTTP request. And iOS, if it is iOS engine, it would use NSURL session. It's a similar class of HTTP URL connection, but in iOS. Then they have tried to come up with a new serialization library, but you can use JSON, your favorite, or maybe Moshi, whichever you are using, you can do it. Since I find it new, I try to explore it. Plus, it also goes well with the rest of the stack. So I thought to use what they recommend, and it came nicely. I think it was quite easy to set it up. Once you have configured your serialization library, what we're going to do is we're going to create a class. Let's name it shared API client, which would use Ktor internally. And then shared API client would use job info class. Now, job info class is nothing but your entity, a simple data class, which holds your JSON data into the data class format. And Kotlin serialization library would do it for you. So and then at the end it just consume that class after passing the JSON information. There is an independent layer, or you can say class, called osinformation.kt. This class is having a simple function which would help you to get the OS specific information. I would go to that use case a bit later, but let's say it has this responsibility as well, and this entire thing fits into the shared module. Remember, you are not in Android project, you are not in iOS project, you are into that entirely separate shared module. Now let's actually start writing the code. We know the diagram and everything. We now maybe have some visualization in our mind. Now let's start writing the code. To start writing the code, you would add this sort of dependency in your shared module. Now pay attention to the title where I am highlighting which file I'm trying to modify. So it is the build.gradle file of your shared module. So you add this dependency just like you are adding in your Android project. The language and approach remains same. It's the KTS file. So I have tried to use the Kotlin DSL for the Gradle file. You add the dependency. There is a concept of source set. So within the shared module, there is something like common main. So whatever you add here, your common source set can access. Then there is Android main. Whatever you add here, Android source set can access. And same goes for iOS. Whatever you add here, the iOS source set would use. Now you might have noticed that I'm using ktor for common main and then try to overwrite kind of a thing for Android and iOS main. Why I'm doing? Because I have to do it. Eventually, what ktor would do, ktor will pick up all this Android and iOS specific dependency and use Android or iOS engine out of it. And that's where it requires this dependency. And core dependency is just a core client, pure HTTP classes and talk around, networking stuff. So what we're gonna get from the server. So let's say it's the array of JSON, and within that array there are JSON objects, and each object holds some meaningful data like ID, what type of job it is, what's the company, what is the logo of company, location, and blah blah blah, job details, JD, and all stuff. And this can be mapped with similar kind of a data class you can create. Now, this data class is also inside shared module. So ultimately, the same data class or entity is going to be used by your Android and iOS project. Yeah. Now we're gonna write the actual class which makes the network call. So let's call it shared API client as per our previous diagram. Again, pay attention, it is still inside your shared module. So you just define the URL, and then here is the important part. So you create HTTP client. This HTTP client is coming from ktor, as I said, and then they have this very interesting syntax, and they try to use more of a harder function, use lambda syntax to make it more readable. So Kotlin is just being Kotlin here. Everything is so cool and readable. So you say install and then JSON feature what you want. So it's if it is retrofit, you can say you are trying to request some sort of feature. You are trying to build your OK HTTP client in context of retrofit and OK HTTP. It's the similar thing. You enable JSON parsing feature. You say what serializer you gonna use. I want to use the JSON serializer for using Kotlin X serialization. So I just define that part. Then calls the function, call it a get job info. It would return us the list of all the jobs which is available for UK market. I'm just trying to build the URL here inside implementation, and then use the same HTTP client which you have created before and call the get method out of it. Now here complexity is not around using get or post. So I have keep it things simple. It's get, but I have evaluated post parameters as well. Passing parameters in your post request is not a big deal. The concept remains same. You pass the parameter from your top layer to all the way to the bottom, and then try to build the request here. I would ask you to notice the way I'm using suspend function. So you are getting benefit of coroutine as well. We will see how this suspend function are consumed ultimately from Android and iOS project. But then there is another endpoint. So you can define all the functions based on your need. Whatever shared API client would offer you, just define all those functions, and then provide your entity class or data class accordingly. Now, once your shared client is ready, this is for now very thin layer of our API client, we can go and start thinking to use in Android. So to use in Android, you just need a project type dependency in your application level build.gradle file. And since it is in the same root directory, you don't need a proper Gradle implementation here. You just provide a project level dependency, and that's it. You get all the classes. And then you can say So we want to create view model, right? And we want to use all the best practices which Android offers. So I want to use the view model. What if now, what should I do? If it is a repository, I would inject the repository instance here, right? Similarly, the idea remains the same. You just inject your shared API client here. Now you can use any dependency injection framework, and then you can say, okay, I want to have a job info property, which is nothing but the live data. Inside your live data, you put an emit statement because eventually you would be emitting all the data. And then just say API client dot get job info. Since live data has idea about coroutine scope and all the context and all the dispatchers, you get pretty much all the stuff for free. You just need to define your function suspend, call it here, and then on a view layer, I'm using view binding. So on a view layer, if it is a you can do something like this: view model dot job info, and observe it, and then get the data back. That's it. View model, using a view model, you just inject it as I explained you here, and then it really changes nothing. On a view layer, you can see there is no KMM specific code, there is no Rx related code, or nothing. It's just a dumb view layer which you would like in any of your project. Now, what if it's an iOS? Now here things may take some time for you because you are an Android engineer. You may not have the complete idea how iOS works. But once you open the iOS project using your iOS job finder application, you can either open in Xcode because there you would get more readability. You can get the editor's help. Android Studio is not good in editing the iOS specific file. But when let's spend some time to understand that how shared framework is doing the magic. So once you set up a plugin, once you write your shared client, the plugin comes with a custom Gradle task, and your plugin also does something for your iOS project. It adds some script in the iOS module. This is the build phase of iOS. You can see this build phase as behaving like if someone requests a build, what step I need to perform. So let's say you need to run a Gradle task, Gradle W shared pack for Xcode. Now remember, this would run every time you build your iOS application, and once this task is run, it is going to build your shared module and convert all the stuff into Swift and Objective-C for you. So let's take a look how things got converted into the Swift compatible code. So once the build is configured, by the way, this plugin is doing for you. You don't need to add this step. This is just for the information purpose. And then you need to link them as well, just like any other framework. That is also done by your KMM plugin setup itself, and that's why plugin is so crucial. Without plugin, you can't get the things done easily. And then when I tried to check what it does behind the scene, I found that for all the shared code which I have written, it tries to transpile into the Swift, or some of the header files were in Swift, and some of the header files were written in Objective-C. I'm not sure what's the reason behind supporting both the stuff, but I imagine it could be somewhere around compatibility, because your shared module would be compatible with your Swift code and Objective-C as well if you are still in some legacy phase. And this entire shared framework supports iOS 9 and above. So from the backward compatibility perspective as well, you can think, the Kotlin team has really thinking and provided a good backward compatibility for even for iOS. Now this code may get bit tricky for you, and because you are not used to see the iOS code, but imagine, and I'm only going to explain how the network layer can be consumed. So let's import the shared. Now shared is our shared module, so we just import that. We create an API client class, a wrapper class, You this is just a constructor, and then here is a function that provides a fetch job list. Now fetch job list would eventually call shared API client dot get job info, and then there comes some very iOS specific syntax where I want to handle some success scenario and error scenario. But then what I call is I dispatch it on the async thread. I transfer that request to the asynchronous thread, and then get the response back, or actually wait until I get the response back. Once I get the response back, I try to map whatever job info entity I have created inside my shared module to maybe something iOS compatible. So that's what I'm doing in the completion function. So that's all in iOS. As I said, after this layer, iOS don't need to worry about. They can just keep on developing the way they are. They can use Viper pattern, they can use view model pattern, whatever they want. It's all possible. Once you consume the function, you are on your own now, and then follow all the platform specific practices. Now, initially I explained that Kotlin allows you to differ by platform if there is a requirement. Let's say what requirement I had. Again, it's a very trivial requirement, and on this particular part, Kotlin multi-platform mobile is proving a bit thin, I would say. I would explain some of the drawback which I feel while working on it. Now, you might notice on this screenshot that I'm trying to display the OS version and API level both for Android and iOS, but my code lives in shared module. But they have a separate path and separate requirement. So requirement is I want to display OS name and version in the app. It should be something like Android OS name API level. For iOS, it should be iOS and version, things like that. So how would you do that? Now, again, we are back to our shared module because we want to write a functionality in our common code base so that Android and iOS can use it. So in the shared module, within your shared module, you can say get OS information. Now this function is living inside one specific class, but the main important part to understand is the expect keyword. Now, and here is there is the entire new concept how you can override some of the platform specific requirements. So you can say expect. That means both Android main and iOS main would expect implementation for this get OS information. So your common module is expecting some implementation. It's kind of a contract, you can say in a simpler term. So now let's go to the Android main, and then in Android main, I try to override it. So it's not the typical override keyword like you use in Kotlin or Java, but you can say actual. So you set your expectation, and then you provide actual implementation for it. That's the gist. So you say actual. All these are keyword, by the way. So you use the actual keyword, you override the implementation, or let's say provide the implementation. Now this typical code is doing nothing but trying to fetch the API level and OS version. You must be familiar with this. If it is iOS, you can again say actual. It is inside your shared module, but inside your iOS source set. Previous was inside Android source set. So you can say actual fun get OS information, and then provide the implementation. And here, just notice how KMM is coming up with some really platform specific name, and that's why I love it. They are respecting the platform. They say UI device. This naming convention is purely coming from the iOS. It's not iOS class, by the way. So don't think that they're trying to access some iOS core frameworks or namespaces. No, it's not like that. They are just mimicking some of the behavior, and these classes comes as a standard Kotlin KMM libraries. It is still Kotlin code behind the scene. You can check the source code and see what they are doing. Basically, they must have created some bridge internally. Now, once you have this part done, here is another interesting topic, and Uncle Bob is furiously looking at you. that dude, where is your test cases? You are not talking about testing. You develop the entire application, but no talk around test cases. It's not fair. So I evaluated few stuff around testing as well. Um, let's jump to straight to the main part. What if I want to unit test my shared API client? The requirement is this harsh. Okay. And then I want to try all this various stuff where I return multiple types of responses. I want all kind of assertion. I want 100% code coverage. Like many of you might be hearing this from your company leads that they want 100% code coverage. So I try to attempt that part. So you create a simple JUnit test class. You just add required dependency in your build.gradle file. Again, it's inside shared module. I would keep repeating this because it is very important to understand for all of you that code lives where, right? We did some switching between Android, iOS shared module. So I'm just keep repeating this to you. Now you can say global scope.launch because we are testing the suspendable function inside our shared API client. Both the functions which are making API call, they are suspendable. So you need this, just a scope to run the suspendable function. You can use any of your favorite mocking library. I was using Mockito here. So you just mocked your instance of HTTP client. Remember, this instance is not the shared API client, but this instance is your Ktor's HTTP client. So you are mocking the internal part, not the actual class which is under test. And then you just provide some dummy information. I have skipped that because it was really lengthy dummy response. So you just provide your dummy test response, and then you call the actual function which is under test, and then you can have your assertion just like normal assertion. You can say assert equal list of what you are getting and list of what you have, and then you can call some verify methods on your mocked instance, and you can say, oh, I want URL to be exactly like this, and then this way you can verify or assert your URLs as well, that it has to match full time, it has to have a location UK. You can do whole lot of stuff. It's up to you how far you want to go. So that was all about testing the JUnit client. Um, Also, let's understand, what if I want to write espresso test case. So let me be very honest. When I was trying to do it, I kind of struggle a lot because with espresso test case, what happens that you need to provide the you need to map your API client and map it to the mock server, let's say if it is a retrofit client. Similarly, here, Ktor also comes up with the Android engine, but I found that Android engine would be more useful if I am using Ktor client directly into my Android project. What if my Ktor client is inside shared and I want to write test cases on my actual Android app? Because that's where I would make the network calls ultimately. So this bit I couldn't figure it out. I'm still trying to work, and I might be doing something wrong setting up the Ktor client, but who knows? Maybe it's the other way around, that maybe something is lacking. On iOS part, again, I was completely clueless that how iOS side can write their test cases as well. In worst case, what we can do is we can change our design a bit, where we try to inject our API client all the way from view layer to the shared module. Maybe this could be the solution, but I haven't got time to try it out there. Maybe in future. But this is where I struggled a lot, and probably you might struggle as well. So disclaimer. And yeah, now whatever we have talked so far, it is all for the greenfield project. It is very easy to start using KMM if it is a new project. For existing project, how do I do? You might have this question. Uh, there is not a proper solution to use it, but then there is an idea that maybe this would work, and this has been suggested by the Kotlin team itself. So let's say you have a new project, then things come easy. You write a shared code in your K module, you implement the native functionality, or I would say UI part in your Android and iOS project, and then ultimately use it in form of jar or the framework file. But if it is existing project, the way you should do is maybe take some time, plan your work in such a way that you can take out some Kotlin written code from Android, refactor it, and make it compatible with iOS, and then use it just like the way you were using for any of the new project. Another good thing which you can do is whenever you have any new requirement coming up in your project, and treat it as a new feature. So if it is a new feature, you can go back to the new project path, because you can easily do the modularized development, move everything into the new module, use or develop it using the KMM approach, and then things would be the same for you. And then this the burning question: is it ready for production? So here is how I evaluated this topic. I'm going to share this with you. So Kotlin ecosystem has developed all these component, and they have categorized them into four modules. Let's say experimental, alpha, beta, and stable. Okay, this means the Kotlin team is very committed towards KMM, because some of the features are already in alpha. uh, they are not going to pull out this entire concept overnight. KMM is something new, and they're going to definitely make a lot of improvement. Just like I experienced back in 2019, I felt that there are a lot of possible improvement required. And in June 2020, half of the problems were gone, and they came up with so beautiful solution about that. So wait for it, I would say. They regularly collect feedback and provide improvement as soon as possible. There are forums where you can give your feedback as a KMM user, and sometimes there could be a situation that they may not guarantee the compatibility, because they are still into experimental and alpha mode. So sometimes they might introduce breaking changes. You never know for the experimental part. So now let's see which component is in which stage. Okay, I have categorized them and broken down into these various topics. So let's say Kotlin slash JVM. We all know it's stable, right? And that's why we are using it. Kotlin is fully stable. There you don't have any surprises. Kotlin native or runtime. Um, so Kotlin runtime is okay, but Kotlin native runtime, it is still in beta. Some of the klib and these binaries are the binaries which I think trying to set the compatibility between your Kotlin code and iOS code. The expect and actual mechanism, the way you can differ or set up a contract between the shared module and the iOS and Android source set, it is in beta. Multi-platform Gradle plugin is in beta. Kotlin native interoperability with C and Objective-C in beta. That means they are still trying to optimize their Swift and iOS generated, Objective-C generated code. Cocoa Pods integration in beta, but much better than 2019, because at that time I remember I used to do everything manually. I run the Gradle task, I link them into the Xcode. It was very tedious process, believe me. But now everything is already there when you open Xcode project, which is great. Multi-platform ID support, they are getting there. It is in alpha, but much more towards the stabilization. The KMM plugin itself in an experimental stage. That means they might change something in Wizard. They might have some compatibility issue with maybe some of the Android Studio version, or maybe the Kotlin version itself. This could happen because it's in experimental state. Some of the references which I find very useful. So there is an official JetBrains tutorial. I think they explain the similar app, but there they are also explaining how the caching can be implemented using local database. So do take a look. It's a nice tutorial. I have set up a link to the companion app which I have created to explain all entire thing about KMM. So all the code, all the screenshot which you have seen in the presentation is part of that companion app. It is on the GitHub, open for public. Do check it out. Leave some feedback over there. There was a talk back in I think July or August when the Kotlin 1.4 event happened, and the fantastic talk has been given by the JetBrains developer advocate itself. It's amazing. They are explaining some of the nuances there as well, which I'm not able to cover in my session. And then some of the FAQs like how can I introduce KMM to my team, what things I need to take care before I start using the KMM, all those kind of a question. I think JetBrains is, as I said, they're collecting the feedback and they are well aware of what developers are facing. So they have nice draft in form of FAQ on this particular link. Do check it out. And that's me with KMM multi-platform. Feel free to ask me any questions. And thanks for your time. Thank you, Kotlin London, for the opportunity one more time.
Thank you. Can you see the questions?
Yes, let me open Slido.
Yeah.
Okay,
Okay.
yeah, so the first question is, how do you run your CI build in Kotlin multi-platform? That's a very interesting question. I think the way I would do is, so let's imagine you set up a KMM project. You set up your Jenkins pipeline and everything around that. What you need to do is, since you don't have Xcode or someone running your Xcode on when you set up a job on CI, if I go back, you might remember that there was a build phase which was using a Gradle task. We need to configure that Gradle task into your build pipeline steps. It's just like your any other Gradle task. So if you say Gradle W assemble so and so, you can say Gradle W shared pack for Xcode, and then this would take a while to build, but eventually set everything and creates a dot framework file for you. So it's possible to set up that steps on CI basically. Okay. Does KMM support Jetpack Compose? And if you use KMM plugin to create a new project, can you specify if you want to use Jetpack? Okay. So yeah, that was the question from Kobe. And I would say, yes, that's possible because on the view layer, KMM has no effect. KMM is not trying to, hijack your view part, and I think they are never going to do that. That's my assumption. And since KMM is not enforcing anything to do on UI side, you can use, of course, Jetpack Compose or the way you are doing nowadays, which is XML based. So yes, possible. I think there shouldn't be any surprises. I would suggest basically, yeah, go for it. Uh, Next question is also from Kobe. Can you not in HTTP client? Then I. So the question is that well, I think this is about the problem where I was trying to explain why Espresso was not easy to set up. So yes, they support different engine. Like for iOS, there is iOS engine, Android, then there is a JS engine as well, because Ktor is also compatible with JavaScript. And that's where I was saying when I got stuck into the problem, I tried doing the same. Where what I did is I tried to rely on the expect and actual mechanism, where let's say I define I want some HTTP client as an expect. Then in Android source set, I define using Android engine, and then on iOS source set, I define using iOS engine. But again, how do you use the same thing into testing? Because in testing, basically you don't get any instance to set your mock data on it, right? There should be some sort of if I relate with the http sorry if I relate with the retrofit, there has to be something like interceptors, which maps to your dummy response. uh, they have put some blogs on their Ktor module, but it's very blurry. I think from a developer perspective, if you see, you would like to see everything together and not in bits and pieces. And nowadays it is in bits and pieces. So you would find how to configure your Android engine. You would find how to set up your shared module, but you would never find how you can do everything in the same module. Even on the test project which KMM has shared with us on their GitHub repository, it is missing all these bits. They haven't clearly highlighted how the unit test cases can be written. They haven't clearly highlighted how espresso test cases are written, how iOS UI test cases are written. And I found that there are a lot of engineers who have already shared this feedback with them. Actually, some of the feedback were on the YouTube video itself on the JetBrains channel. So I think they have got this feedback, and hopefully they are working on it, and they might say us Happy New Year with that kind of a change. So give some time over there, I would suggest. All right, let's move to the next question, which is from Sherwin. How to write KMM library, not app? Is there any document or source for that? Hmm. I think you are trying to ask that you want to develop an independent module using KMM, and maybe mm, not use it in the way directly like I showed you, right? So shared module was part of your overall Android project. It comes as in a same root level, and I think you want to extract it even from there, put it in a separate code base, and completely treat it as a separate code base. Um, so I think it should be possible. I haven't tried it, first of all, so I could be either like total wrong, but based on my exploration so far, I think you can do it. And the way you can do it is, and why I'm saying I can do it, because in the build.gradle file, if you check out my project, my GitHub project, which I would be sharing with the presentation, you can see that in the build or gradle file, there is a source set, and the way source set are configured, and the way module is created, it is basically any other Gradle project. And once it is a Gradle project, once it supports a particular uh, directory structure using source set, I think it is easy to manage them on CI, easy to trigger a separate build, get the output from somewhere. So it goes same. You can say Gradle build, it would start building, then create either a jar file, or basically the build folder. And if it is iOS related stuff, again you run the same task. You can say pack xcode, sorry, I think it was pack for xcode, yeah, something like that. So you run this task and it should generate you. But yeah, I'm not too confident. I would say I'm 70% confident that you can use it as a library, but rest 30% is bit gray area for me, to be honest. Okay. Any reason to, next question is, any reason to start the migration from bottom to top? Uh, yeah, because if you think, there is not really much to do on the UI side, right? So if you start from top to bottom, what you would do? There is nothing for you. So what you can do is, in parallel, you can have a shared module being developed. Maybe try using that shared API client with very, a tiny part of your app, which is not uh, carrying too much information or not having complex requirement. You can use it, to fetch maybe profile data, some of the contact details, really light requirements, see how it goes, because your main application might be using other stuff like Rx, or even Flow. Now you would try with Flow, since Raúl explained it, right? So that's possible as well. You might be using Flow, you might be using some other kind of reactive programming, and there maybe situation would be a bit tricky, and that's why I explained in the slide that for existing project it may not be that much straightforward. You may need to figure few things out, like from where to start. Start with the smallest module, of course, that would be the idea. Start with maybe data classes. You can start putting your data classes into shared module. That would be a good start as well, and there is a no risk. So yeah, I would suggest you to start from the bottom layer only. Okay, having said that, I think there are no more questions, so I can hand it over to Enzo.
Yeah,
Thank you
thank you
once
very
again.
much. Thank you very much, Hardik. And if you like this talk, you can rewatch Hardik's talk back a few months ago. He was talking about flow, so it's very complementing with the talk we had with Raúl. So thanks again, Hardik. I hope you can get you once again, like back in the
Yeah,
few months' time, maybe.
yeah,
Get ready for
sure,
another talk. Thank you.
definitely.
So that's all. Thanks again to Raúl and Hardik for being with us today. Thanks so much for tuning in and following us doing this month. We tried our best to give you the talks, very interesting talks. Hope you enjoyed all these events we did this year. Remember, you can rewatch it, as I just said, here on YouTube. From me, Guillermo, Pablo, and Amar. Enjoy the holidays and stay safe. See you in January again online with more Kotlin talks, and let's hope to see you face to face very soon. But for now, bye.